Hey guys, check this out. This is my new treadmill or walking pad, whatever you want to call it. And I love it so much more than I thought I would, because on one side it has your regular walking or jogging mode, but when you flip it around, it has these bumps under the belt where it will massage your feet. I use it when I edit or 3D model, but honestly I use it about 80% of the time I'm at my desk. It came with these 3 accessories: a remote control, a battery cell, and some belt lubricant. And usually when accessories like these come with the stuff I buy, they usually end up in the junk drawer. But this time I decided to put a stop to that because now I have a 3D printer. So I printed out a way for these to not get lost, and instead I'm gonna mount them neatly on my treadmill. I also wanted to go the extra mile to get the cord organized, so I went from this to this. Let me show you how I modeled these mounts. First, I'm gonna show you how I made this plug mount. So I started with the sketch. I started with a center rectangle that measures 72 millimeters tall and 50 millimeters wide. After that, I extruded it 3 millimeters. Then I'll make a line sketch that goes down the center, and this will come in handy in just a minute. Now I'm gonna import the image of the plug and scale and align it vertically as best as I can. So to scale it, I sketched a rectangle that measures 30 millimeters tall by 30 millimeters wide. And the plug at its widest point is 23 millimeters wide. So I know that when the image and the rectangle match at their widest, everything else will automatically match too. Now I'm gonna add the arms that go on either side of the plug. After I create the left side, I can select all the edges and mirror it with the center line sketch that I made just a minute ago. At this point, I realized that my mount was unnecessarily tall, so I'm just gonna resize it to a size that makes more sense. Now I can select both sketches I just made and extrude them out 12 millimeters. So at this point, my screen recording app ran out of memory without warning me, but good thing I caught it on time. I can go back a bit on the timeline and show you that all I did was fillet my bottom edges, then these 4 corners, then finally these top edges. Next, I will fillet these 4 outer corners. Finally, I fillet these 4 smaller edges, which by the way, I only need to fillet one side, and it's gonna affect all connecting edges because I have this tangent chain box checked. Now I'm gonna show you how I made this remote mount, and here's the idea of how I'm gonna use it. So for this one, I started with the sketch. I selected the front facing plane. Then I used a center rectangle that measures 40.2 by 40.2 millimeters. The remote measures 11.65 millimeters thick, so that is what I am going to extrude. Then I selected the shell feature and selected the outside features, since the mount will go on the outside of the controller. I had the shell feature grow the box out by 2 millimeters. So I clicked the top of the box so that the top would be the only face removed. Then I made another sketch on this top face of a rectangle that measures 2 millimeters by 36 millimeters. That sketch is going to be used to extrude all the way down. I also got rid of this face, which I think helps reduce the use of filament. Plus it helps me mount the remote in whatever orientation I want. Then I made a 50 millimeter by 50 millimeter square sketch on the back of the mount, just so that I could match the thickness of my treadmill. I then went over these faces and sketched a triangle so I could extrude cut these corners. I think it's a good design practice to cut these corners because it adds a little bit of sleekness. But more importantly, it's gonna help reduce the mount from getting caught in clothing, and it won't rub harshly against your skin if you accidentally rub maybe your foot against it while you're walking. So don't do what I did here and fillet the small edges first. I've learned that it's best to fillet your larger, more noticeable fillets first, then do your smaller fillets towards the end. And in hindsight, I feel I should have given these edges some fillets to give them a little bit more strength. Now I'm going to show you how I made this battery mount, which holds this battery cell like this. Plus I made the cutouts so that you can just easily pull the battery out. So I started a sketch from the front plane. I made a center circle with 30 millimeter diameter. Here I forgot to mention that I extruded the circle by 3 millimeters. Then I finished the sketch. Then I made another sketch with 24.5 millimeters and also finished that sketch. After this step, I realized that my first circle was unnecessarily thick. So instead of starting over, I just went back on the timeline to resize the first circle to 28 millimeters. I then extruded the outer circle 5 millimeters. Then I opened the construct menu to choose a tangent plane to create a new plane on the outside of the cylinder. After selecting that plane, I just made a 2-point circle sketch starting from the origin. The circle measured 22 millimeters. And then I finished the sketch. I cut extruded the circle to the opposite side, and this cut will let me grab the battery easily. I then gave these 4 edges a nice fillet, and I finished the design by filleting these edges as well. Finally, I'm going to show you how I made this mount, which is made to hold this treadmill lubricant, and this is the way it's going to hold the bottle. For this mount, I started with the sketch on a square measuring 30 by 30 millimeters. Then I extruded it to another 30 millimeters to make a perfect cube. Then I sketched a circle on top of this cube measuring 26.2 millimeters, which is 1/4 of a millimeter less than the diameter of the lubricant container that actually measures 26.5 millimeters. I did this just so that it would fit the bottle just a little bit more snug, and also the circle is a little offset to one of the sides so that in a minute when I fillet it, it will look nicer. Here, I forgot to mention that I cut extruded this circle all the way to the opposite side. Then I cut extruded this side by 5 millimeters so I could snap the bottle in from the front. Then I did the most important one of these 3 fillets here and here. Then I did these inside fillets, and then finally these outer ones. So as the final tip, I'm just going to show you what you can do if a print like this didn't come out as you wanted. As you probably remember, these sides I wasn't happy with because they didn't come out with fillets. I forgot to add them myself. So I'm going to show you how to go back and make a correction. So I'm going to reopen my treadmill remote mount. Remember that we want to use F3D files for this. So I'm going to open that up, and here we have a file with a timeline and everything. We can edit anything we want from here. So in this case, there's nothing that we really need to go back to change. In fact, all we got to do in this case is control, click that edge and this edge too. Then we're going to add a fillet. And something like this could work, you know. It's subtle, but it's still obviously there. It's just going to give it a little bit more strength. What happens if we give it 3? Yeah, that looks nice. And from here, all you got to do is just go back and send it out as a 3MF or STL file to your 3D printer, and you're good to go. In fact, that's what I'm going to do right now. I'm going to export this treadmill remote mount F3D file. Do you want to replace it? Yes, I do. Now I'm going to export as 3MF. Replace, yes. The last file there is to export it to is STL. Export and replace, yes. Audio orient. And if we zoom in, we'll see that, there we go. And now the curves are there included right here. And this model only takes 24 minutes to print. So here I've applied double-sided tape to my mounts. My battery cell fit perfectly. This is a good place to put it. It's out of the way of the cord. And here I placed my mount for my remote control. And this is actually a chain mount for my blinds. My previous video shows how I designed this. And I'm just testing my double-sided tape to see if it holds pretty well. And it does, because it pulls up that entire side of the treadmill. And here I am putting the mount for my plug, and there's as little slack as possible. And here you can see that I decided to put a magnet on the mount for my lubricant, because sometimes I'm going to be standing it up on its side, and sometimes it's going to be flat on the ground. I'm going to have to store the lube in different orientations. Let me know if this video was helpful for you in any way, and if anybody wants the files for the 3D prints or the Fusion files to edit them, you guys can find them in the description below. Thank you so much for watching.